Hi! Today we're going to learn about the interval of convergence. Let's say we have to calculate the interval and radius of convergence for the series from n equals 0 to infinity of n times x plus 2 to the n power over 5 to the n minus 1 power. So how do we do this? Well, let's use the ratio test. Now, I know what you guys might be thinking, but the ratio test just tells you whether it's convergent or divergent, or it's inconclusive. But we have an x in here, and that means that our answer in the ratio test will also have an x. So, if we have an x in the answer, then we can figure out for what values of x is less than 1. And that would be the radius of convergence. So let's actually do the problem and try to understand that. So the ratio test says we have the limit as n approaches infinity of the absolute value of a sub k plus 1 over a sub k. So we know that this would be the limit as n approaches infinity of the absolute value of a sub k would be n plus 1. Let me just erase the ratio test definition and start from there. So we have, this would be the limit from n equals, as n approaches infinity, of the absolute value of n plus 1 times x plus 2 to the n plus 1 power. Note that n will take the place of k in a sub k plus 1 over a sub k over 5 to the n power, because n minus 1 plus 1 is n. And you multiply this, or you divide by a sub k, which is this, or multiply by the reciprocal of this, which is 5 to the n minus 1 power over n times x plus 2 to the n power. Absolute values closed. So we can simplify what's inside this limit. So here we can see that both of these have the same base. We have 5n and 5 to the n minus 1 power. So that means that this would be equal to 5 to the n minus 1 power minus n. And we get 0 here. So if we have this, then we get the n's cancel out, and we're left with negative 1. So we get 5 to the negative 1 power. So if we have 5 to the negative 1 power, then that means that this 5 gets cancelled out of the numerator, and we're just left with a 5 in the denominator. A 5 to the first power in the denominator. So this was originally 5 to the n power, n minus 1 power, and this was originally 5 to the n power, and because of exponent rules, we get just 5 in the denominator. Now, in the numerator, we also have two exponents with the same base. It would be x plus 2 to the n plus 1 power and x plus 2 to the n power. So that would be x plus 2 to the n plus 1 minus n power, which is just x plus 2 to the first power, or just x plus 2. So now let's rewrite this limit. We get the limit as n approaches infinity of the absolute value of n plus 1 times x plus 2 over 5n, which is equal to, so because this x plus 2 would be a constant if we just had one value in for x, because x isn't the thing that's increasing or decreasing, x isn't a variable in this case. Because it's a constant, we can pull it outside of the limit. So this would be the absolute value of x plus 2 times the limit as n approaches infinity of n plus 1 over 5n. So, what would this limit be equal to? So we know this is a rational function, And so that means that as n approaches infinity, it gets closer to 1/5. Or we could have used L'Hopital's rule to figure that out too. So this limit is equal to 1/5. It's equal to 1/5. So this is equal to 1/5 times the absolute value of x plus 2. So is this greater than, less than, or equal to 1? Well, we don't know because we have x inside. So let's make an inequality. For this to be convergent, the ratio test says that this must be less than 1. So let's set this as an inequality less than 1. So 1/5 times the absolute value of x plus 2 is less than 1. That means that the absolute value of x plus 2 is less than 5. Meaning that x plus 2 is less than 5 but greater than -5. And let's start moving this way. So now we just have to isolate for x. That means that we have to subtract 2 from both sides. So we get x is less than 3 but greater than -7. So we have a sort of interval here. We have x is less than 3 but greater than -7. Now at these 2 points, the ratio test says that this would be equal to 1. So if we plug in -7 and 3, because of our inequality, and we would get, if we plugged -7 and 3 for x in this equation, we would get 1. Now the ratio test says that when it's 1, when the answer is 1, the test is inconclusive. So that means that we have to do something else to figure out whether the endpoints are part of the interval. But let's first do the radius of convergence, because that doesn't matter, that doesn't care about whether our endpoints are inside the interval or not. So, there are 2 ways we can calculate the radius. The first would be finding the center, where x is. So the center would be at -2, because if we plugged in -2 for x, this would all be equal to 0, because we would have -2 plus 2, which is equal to 0, and 0 to the nth power is 0, and then we have anything divided by or multiplied by 0, or anything multiplied by 0 is 0, and anything that is 0 divided by another value is equal to 0. So we could use -2 as the center, or we could calculate the total length of this interval and divide it by 2, because the total length of this interval would have to be the diameter, meaning that half of it would be the radius. Either way, if you do that, you get the radius of convergence is equal to 5. And if you ever get a radius of convergence that's negative, try it again, because the radius can never be negative. Or cannot be negative. So, now we're going to have to figure out whether the endpoints are part of the interval. But before we do that, we need more space. So take a moment to go over this again. So now let's write this interval up here. We get x is less than 3, but greater than -7. So, how do we figure out whether those endpoints are part of the interval? So let's plug in those endpoints into the series. So we get the series from n equals 0 to infinity of n times, instead of x we have -7, -7 plus 2, which is just -5, -5 to the nth power over 5 to the n minus 1 power. So this would be equal to, so let's just take this numerator here, n times -5 to the nth power. This would be equal to n times 5 to the nth power times negative 1 to the nth power, and let's also take the denominator here, over 5 to the n minus 1 power. So if we do that, then we get, because these are the same bases, then we can use exponent rules. So we get 5 to the n minus 1 power, so that becomes the n's cancel out, and we have minus negative 1, which is positive 1, meaning that this denominator becomes 0, and we just have 5 in the numerator for that exponent. So this is equal to the series, whoops, did that wrong, the series from n equals 0 to infinity of n times 5 times negative 1 to the n power, or 5n times negative 1 to the n power. So, as you can see, this is an alternating series. So, if it's an alternating series, we can use the alternating series test to figure out whether this is convergent or divergent. So, the alternating series test says that we have this alternating part over here, and then we have this r. So r is just naming this a sub k part, or the actual series, and if the limit as n approaches infinity of r is equal to 0, then that means that it is convergent. So let's do that. We have the limit as n approaches infinity of 5n, which is equal to infinity, meaning that it's divergent. So this limit is equal to infinity, meaning that it's divergent. So that means that negative 7 is not in the interval. So, what about negative 3? So we know that, or let's just first write that first bound of the interval. So we have the interval of convergence. The interval of convergence, on the left side we have a parenthesis, then a negative 7, comma, and it's parentheses because negative 7 is not included. And now we're going to have to figure out whether 3 is included in the interval. And we need more space, so before we do that, take a moment to go over this. And now we'll do 3. So we have the series from n equals 0 to infinity of n times 3 plus 2 is 5 to the n power over 5 to the n minus 1 power. So we have 5 to the n power over 5 to the n minus 1 power, which just becomes 5 in the numerator. So we're left with 5n in the numerator. Let me redo that. So we have n times 5 to the n power over 5 to the n minus 1 power, which is equal to the series from n equals 0 to infinity of 5n. Because we have 5 to the n over 5 to the n minus 1, which is equal to 5 to the n minus 1. So 5 to the n minus, in parentheses, n minus 1, which is equal to 5 to the first power. So we get this series here. So we can use the nth term test, or the divergency test, to figure out whether this is divergent. And it says if the limit of a sub k as n approaches infinity of a sub k is not equal to 0, then the series is divergent. So let's figure this out. We have the limit of 5n as n approaches infinity. So the limit as n approaches infinity of 5n would be equal to infinity, which is not equal to 0, meaning that this is divergent. So because it's divergent, 3 is also not included in the interval. So we have comma 3 in parentheses closed. Or you can write the interval as x is less than 3, but greater than -7. And if one of those or both of those were included in the interval, then we would have greater than or equal to or less than or equal to. But they're not in this example. So, the answers to this problem are the radius of convergence is equal to 5, and the interval of convergence is equal to parentheses -7, comma 3 parentheses. Today we learned about the interval and radius of convergence. Thank you for watching this video.